Mr. Clown here for Clown Maths. Today we're going to do the cosine rule. We're going to learn how to find the angle, how to find a side. Let's get straight into it right now. Cosine rule is used in triangles to find lengths or angles, and I'm just going to go straight through into the formula for the cosine rule. So I've got a triangle here, ABC. Just remember we can label opposite sides as A and B and C like so. So I can just say that is A, that is little b, and that is little c. So the cosine rule for a triangle to find a length, well, you're giving it to start with exam paper in National 5 Maths, but remember that's ABC. We start off with A, and it's A squared equals B squared plus C squared minus 2BC cos A. Well, what does that actually mean? It means, if we look at what we've been given, if we've got this angle and the opposite side we're trying to find, then we do the two sides that are making up the angle, B and C, making that kind of V shape, B squared plus C squared, minus 2 lots of B and C times the cos of the angle that you're given. And remember, we're not going to use the letters too much. We're going to think about the shape that it makes, that V shape, and decide what is A for when we're doing individual questions. Let's look at the other version of the cosine rule. We can rearrange this formula so that we can work out cos A. Luckily, you don't have to rearrange it yourself. You're given it in the exam paper if you're doing National 5 Maths. But I'll write it out for you. It's similar to the above. Before, it's still B squared plus C squared. Then it's minus A squared. And then we're dividing by, so it's over 2BC. And again, you're given that in the exam paper. So let's go straight into examples. One, calculate the length A. Correct to one decimal place. And you might be wondering now, well, I know the sine rule and I know there's a cosine rule. What one do I use? And here's a simple method for you. Obviously, this video is doing the cosine rule, so all the examples will be cosine rule. But if you count the sides, I've got one side given, two sides given, and I'm finding the third side. That's three sides. Three sides is cosine rule. If you've only given two sides, you're not asked to find the missing side. It's the sine rule. So cosine rule, so I write down the formula from the start of the exam paper. A squared equals B squared plus C squared minus 2BC cos A. And now I just substitute everything in. So B is the opposite here, so that's B. And opposite C is here, so I just shove my numbers in. So I've got 56 squared plus 41 squared minus 2 times 56 times 41 times the cos of the angle, which is 17 degrees. So this is a calculator job because that's A squared. So we get our calculator, 56 squared plus 41 squared minus, and I usually open a bracket at this point, 2 times 56 times 41 times the cos of 17, and we close our brackets, and we get an answer of 425.64856. Now that's A squared. We could have square rooted straight away, but it involves lots of brackets, so I like to find A squared first. So I'm just going to write that down, 425.64856. And now to find A, it is simply square root that answer. So 425.649. We'll round it to one decimal place later on. As long as we've not over rounded in the middle, so 3 decimal places seems reasonable. So square root 425.649. That gives me 20.6 to 1 decimal place. 20.6, and there's no units in this question, so I'm done there. To calculate the length using the cosine rule, this time it says calculate P to 2 decimal places. So again, how do I know it's a cosine rule anyway? I've got the side I'm missing, 1, then 2 other sides, 2, 3. 3 sides, cosine rule. Now this time, I'm going to write down the cosine rule for you, but you'll notice these letters are not in our triangle. A squared equals B squared plus C squared minus 2BC cos A. But that is okay, because we don't want to think in letters, because it could be any letters are given you in the question. What the main thing is the angle, as long as you've got this angle here, and the sides either side of that angle is your big A. So I'm just going to put my big A there, then that's my little a. And then the B and C, it doesn't really matter between the two sides, as long as one of them's B, one of them's C. So I'll just call that B and that C for the sake of it. 24 squared plus 40 squared minus 2 times 24 times 40 times the cos of 105 degrees. 24 squared plus 40 squared minus open bracket 2 times 24 times 40 times the cos of 105. Close the bracket. We get 2672.933. 2672.933. So A is the square root of this number, 2672.933. Notice I've not rounded yet, not majorly, 3 decimal places, because I want my final answer to 2 decimal places. So we need a nice long number before we do that. If you round twice, you'll be double rounding, and that'll be very inaccurate. So 2672.933 gives me 51.70 to 2 decimal places. 51.70 in the units 1 meters. And we're done there. Example 3. Using the cosine rule to calculate an angle, this time just angle A. So we're given angle A, so opposite A is little side A, opposite B is little side B, and opposite C is little side C. Again, I know it's the cosine rule, but by counting the sides, I'm given 1, 2, 3 sides. 3 sides is the cosine rule. So I copy my formula from the start of the exam paper. Cos A equals B squared plus C squared minus A squared all over 2BC. So the big one that you need to be aware of is getting the A right. We have to calculate this angle here. So opposite side is the A. In this case, we're given the correct letters, but in future examples, you'll be given the wrong letters. So B squared plus C squared, 19 squared plus 13 squared minus 8 squared for A, all over 2 times 19 times 13. So A, that's cos A. So A is the inverse cos of that whole formula. 19 squared plus 13 squared minus 8 squared, all over 2 times 19 times 13. So you can do that in one go in a calculator if you want, or just calculate the previous bit first and then do inverse cos. I'll do it in one go. So I get my calculator, shift cos, open bracket, 19 squared plus 13 squared minus 8 squared. So there's my top bit for the bracket. And I'm dividing by, open another bracket, 2 times 19 times 13. Close that bracket, and then close the bracket that the calculator gave me to start with. Although not massively required, you get 19.38. So 19.4 degrees to 1 decimal place. And we're done there. Cosine rule, calculating an angle. To calculate angle P to 1 decimal place. So again, I know it's the cosine rule because I've got 1, 2, 3 sides. 3 sides, cosine rule in a triangle. So I copy my formula from the start of the exam paper. Cos A equals B squared plus C squared minus A squared all over 2BC. Now notice in this question we're not given ABC, we're asked to calculate the angle P. So P has become our A because that's the angle we're trying to find, but the opposite side then is our A. So that's our A in our formula. If we can get that, we're done. Well, way to remember it is, for the angle, the sides that make up the angle are your B and C, and the other one is A. So B and C can be either of A2, it doesn't matter which way around, so I'll just call that B and C, and I'm good to go. So subbing it in, I get 24 squared plus 37 squared minus 17 squared over 2 times 24 times 37. So that means that A is the inverse cos of this sum. 24 squared plus 37 squared minus 17 squared over 2 times 24 times 37. So I need to do the inverse cos in my calculator. So I get my calculator, inverse cos, shift cos, open bracket, 24 squared plus 37 squared minus 17 squared, close bracket divided by the bottom, 2 times 24 times 37, close brackets, 21.182. It was the 1 decimal place, so 21.2 degrees. And we're done there. The cosine rule, let's look at some past paper questions. Remember, cosine rule is also given to you in the exam paper. The key points with the cosine rule are, if you're given all three sides of a triangle, you can use the cosine rule to find an angle. If you're given one angle but two sides that go across the angle, you can use the cosine rule to get the other missing side on the other side, okay? So let's have a look at this. 8th grade National 5 Maths 2015 paper 2 question 3 says, triangle A is shown, calculate the length of AB, so I have to calculate this length here. Remember, the cosine rule at start exam paper says A squared equals B squared plus C squared minus 2BC cos A. But that is when A is the angle in the opposite side. All you need to remember is the two sides go across the angle. If that's the case, that's your two sides, your B and your C, and that's your angle. So I can immediately just say that I've got 1.2 squared plus 1.35 squared minus 2 times 1.2 times 1.35 times the cos of 35 degrees. And if you can get that far, you get a mark. So remember, that's squared. I'm just calling this A to be clear. So you need to do some work in your calculator. You can do it all in one stage, or you can do it in bits. If you're going to do it in all in one stage, you could put that brackets around this bit minus brackets around this whole bit, and it'll give you your answer in one stage. Or you could do the answer to that and write it, minus the answer to that and write it, and take your time. Whatever you do, as long as you be careful with your calculator, you will get 0.608. And a bunch of our numbers. And then you just square root your answer, because that's A squared, so A is the square root of the answer I just found out, which is equal to 0.78 kilometres. Cosine rule, National 5 Maths 2016, paper 2, question 16, had this one. It shows you a diagram. DE is perpendicular to AC. It's part of perpendicular, means at right angles. AD is 4 is shown. DB is 6 is shown. And AE equals EC, which equals 3 centimetres, which is shown there. Put a big question in this one. It says calculate the length of BC, give your answer to one decimal place. So let's have a diagram and have a look at what they're asking us. BC is here, so to calculate this length here, I've just highlighted for us. And obviously it's a triangle, so the clue here is that it's going to be maybe the cosine rule or the sine rule. Now, have we got any angles? No. So if we've not got any angles, we can't use the sine rule or the cosine rule to calculate a side. So the first thing I'm going to do is calculate an angle, because I've got one whole length, two whole lengths. So I need an angle to calculate the third length with the cosine rule, and the angle I need is opposite that side, which is here. So I'm going to calculate angle A. And I'm just going to use standard SOHCAHTOA right angle trigonometry for that. We've got A, that's the opposite side, that's the adjacent, and that's the hypotenuse. So we can say that adjacent over hypotenuse is cos. Cos of A is equal to 3/4. So A is the inverse cos of 3/4. And we can just work that out using a calculator. Inverse cos of 3/4 is 41.4 degrees. The other way you could have worked this one out is just using the sine rule within that small triangle to get the angle. Up to you, but you get 41.4 degrees. And now let me just draw out my triangle. So we've got one big long bit, one bit that goes down there and along here. There's the big triangle, and we know that this is 41.4 degrees. Let's call that A, B and C. And then we know this bottom length must be 6, because it's 3 plus 3. So I can write 6 centimetres. We also know this big long length here is 10, 4 plus 6. So now it's a simple cosine rule question. How do I know it's a cosine rule? Because I have to work out this size here, A. I've got 1, 2, 3 sides, including the missing side. That's the cosine rule. So going to the start of my exam paper, I copy the cosine rule for a side. A squared equals B squared plus C squared minus 2BC cos A. Subbing everything in. Our B is this side here, and that's our C. So we have got 6 squared plus 10 squared minus 2 times 6 times 10 times cos 41.4 degrees. So we can now just get our calculator. 6 squared plus 10 squared minus, I'll open a bracket at this point, 2 times 6 times 10 times cos 41.4. Close the bracket on the angle, close the bracket on the whole sum. I get 45.9866. Let me just copy that down. A squared is 45.9866 with a bunch of other numbers. Don't round at this point because you now need to square root your answer. A is the square root of 45.9866. So again, the calculator comes out 98667, so 9867. So square root A 45.9867, although it won't matter too much if you mess that up. If you put 66, you'll get the same answer. So you get 6.781. And then just check how many decimal places did it want. 1 decimal place. So we write 6.8 centimetres. And we're done there. SQA National 5 Maths 2017 Paper 2 Question 3 had this question. It says PQ is 250, PR is 180, and this is the angle. And it's building a fence around this. We want to wish to build a fence alongside QR. What is the length of the fence? So we need to work out the length of QR. So once again, just checking, as long as I've got the angle in the sides, either side of the angle, I can use that to cosine rule to find the opposite side. So I'm going to label this side my A. We could even call that angle A if you want, just for the sake of it. And then that would be my side B and that would be my side C. Doesn't really matter which is which. So we write down the cosine rule from the start of the exam paper. We'll always go back and check it. B squared plus C squared minus 2BC cos A. Substituting in 250 squared plus 180 squared minus 2 times 250 times 180 times the cos of 147 degrees. Remember, we could do that in one step in a calculator. Put brackets around this, minus brackets around the whole of this, and you will be fine to go. And if you do that, or you take your time on it, you get 170,380.3. And that's A squared, remember though. So that's just got 2 marks so far, substituting and getting A squared. So now just calculate our A. The square root of 170,380.3. And you get an answer of 412.77 meters. National 5 Maths for 18, paper 1, question 10. So this is a non-calculator. It says side x, z is 10, zy is 8, cos z is 1/8. Calculate xy. So it tells you the cos of z instead of the angle, so you don't have to work it out. But it's still cosine rule, because I've got 2 sides and the angle in between to find the opposite side. So if I just call that my A and that my A, I can just change that to an A. So then we've got A squared equals B squared plus C squared minus 2BC cos A. Substituting in, that is 10 squared plus 8 squared minus 2 times 10 times 8 times, well, the cos of A is 1/8. Non-calculator, so you're just going to have to do some non-calculator work on this, I'm afraid. 10 times 10 is 100. 8 times 8 is 64. Luckily, I've got 8 times an eighth, so that's 1. 1 times 10 is 10, times 2 is 20. So take away 20, which gives us a final answer of 144. But remember, that is A squared. So A is the square root of 144, which is a nice round number, which is 12 centimetres, because 12 times 12 is 144. National 5 Maths 2021, paper 2, question 7. The cosine rule with bearings this time. A fishing boat in the yacht left the harbour at point H. The fishing boat travelled 3.4 kilometres. That is shown as in the diagram. On a bearing of 47 degrees to point F. I'll put that in a minute. and he got travel 5.7 kilometers as shown on a bearing of 115 to point Y. We have to calculate the distance between the fishing boat F and the yacht Y. So we have to calculate this distance here. So I know it's going to be the cosine rule because I've got one side there and then the two other sides there. So the angle I'm going to need is this one. But with bearings questions, just calculate as much as you can before you get into your cosine and sine rule. So let's start annotating this diagram. The first bit of information key is the fishing boat left the harbour on a bearing of 47 degrees to point F. So bearings go clockwise from north. So I now know that this is 47 degrees going round to that line. The second bit of information we're told is the yacht travelled on a bearing of 115 to point Y. So there's a little bit of work to do here. It goes north and it goes all the way around here is 115. So if I kind of take a note of that at the side, I know we've got this sort of picture with 115 to here, 15 to there, but we've kind of got this line cutting it which goes to F, and that bit in there is 47. So we can work out this bit in here just by doing 115 minus 47. Don't give yourself a headache, get a calculator for all sums and calculator papers. 115 minus 47 is 68. So I can now write in my diagram that this is 68 degrees. And now I've got everything I need to do for cosine rule, and I can't actually work out any more angles using just normal triangle trig. I can't work out any more angles just using angle rules anyway. So going straight into the cosine rule, I've got three sides and I've got the angle in between two sides to find the missing side. So I'll call that my A. Cosine rule from the start of the exam paper is A squared equals B squared plus C squared minus 2BC cos A. So A is our angle, which is this one, the one inside the triangle. The opposite side is A. And then the other two sides are B and C that make up the angle. So I'll just call that B and that C for the sake of it, for something to sub in. So then we'll just sub in our numbers. 3.4 squared plus 5.7 squared minus 2 times 3.4 times 5.7 times the cos of 68. Using a calculator then, 3.4 squared plus 5.7 squared minus, open brackets, 2 times 3.4 times 5.7 times cos 68. Close the bracket for the angle and close the bracket for my own bracket is 29.5302. 29.5302. There's more numbers, but I'm not rounding here yet. Square root 29.5302 equals, so this is going to be my A, because A is the square root of A squared. 29.5302 square rooted is 5.434. And a bunch of other numbers. Let's just check what we want us to calculate. It doesn't give us a thing to round it to, but everything else is one decimal place, so I'll just write 5.4 kilometres and be done there. And that's me done that one. Free paper 1 question 6. AC is 5 metres, BC is 6 metres, cos C is a fifth. Calculate the length of AB. So this is one of those questions where we're using the cosine rule, but we're giving you the cos of the angle so you can just go straight away. So let's remind ourselves of the cosine rule. Let's start with the exam paper. The cosine rule is A squared equals B squared plus C squared minus 2BC cos of A. Now that's just a generic A, B and C, remember, so you can either relabel your sides to get your A, B and C where you want it, or just remember that the side A is the one opposite the angle you're given, which is cos C. So I'm going to do it that way. I'll just call that my A, and I'll just call that my B and C, and therefore that's my little a there. So I can say that my A squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cos of A, which is cos of C, because that was originally C, remember, so that's a fifth. And now we can start working on that. A squared equals 25 plus 6 sixes is 36. 2 fives is 10. 10 sixes is 60. A fifth of 60 is 12, so minus 12. So a squared is 36, 46, 56. 61 minus 12 is 59, 49. And therefore a is the square root of 49, which is just 7 meters. And then just to answer the question then, it says calculate the length of AB. Length of AB equals 7 meters. And that's just to be on the safe side because I've relabeled the sides, but you'll probably be fine if you didn't do that. 2014 paper 2 question 10 was in a race, boats sail around the three buoys A, B and C in the diagram below. B is 8 kilometers on a bearing of 60 degrees. C is 11 kilometers from B, A is 13 kilometers from C, and the first part of the question is calculate the angle ABC. So they've given us a diagram in this case, so we can just get started straight away, A to B to C. It's this angle in here, so just take a little note of that. That's this one. And if we just check, if we're given three sides of a triangle, and we can always calculate an angle using the cosine rule if we already know all three sides. If we have opposite pairs, an angle on a side, and then maybe a side, and we're trying to find the missing angle, that would be the sine rule. So in this case, it's the cosine rule. So a reminder from the start of the exam paper. So cos A equals B squared plus C squared minus A squared over 2BC. Now, there's a couple of ways to think of this. When they say cos A, they mean the angle you're looking for, we're calling A. But in this case, there's a B attached to this, so don't get too confused. It is always, the angle, the one you take away, is always opposite it. So 13 is my A here. If you want to avoid confusion, you can draw yourself a little diagram, like so, and go, right, I'll call that A because that's the angle I want, and then my 13 is my little a. Then the other two sides would be B and C, so that would be B at 11 and C would be the other side, which is 8 kilometers. So we can say that the cos of our angle equals 8 squared plus 11 squared minus 13 squared over 2 times 8 times 11. And you would get a mark at that point for substituting in. And then we need to work this out. So cos A would equal, using a calculator, you would do 8 squared plus 11 squared minus 13 squared, get an answer, then divide by 2 times 8 times 11, making sure you're using brackets, and you would get 0.09. With a bunch of other numbers. So then to get an angle, we need to do the inverse cos. So the inverse cos of 0.09 equals 85 or 84.8. So 85 degrees would be a reasonable degree of accuracy, or if you got 84.8, that would be fine. So just to answer the question, remember they said angle ABC. I would then write, to be very clear, angle ABC equals 85 degrees. And we're done there. So now for part B says, hence find the size of a shaded angle. Well, we've already worked out that now this is 85 degrees. And it says find the size of this angle here. So we're going to use some angle rules. We know from the previous example that I did before that if you've got two north lines, the angles inside those north lines add up to 180. So I can immediately just diagram do 120 there, because 120 plus 60 is 180. And our second rule, we often use angles around a point add up to 360. So we can do a bit of work and say 120 plus 85 degrees is equal to 205 degrees. So we get 360 minus 205, which just gives us an answer of 155. Obviously, if you kept your answer as 84.8 for part A, then you would write 155.2 instead. 1 mark for working out what you need to take away from 360, and the final mark for calculating it, of course. Okay, last one, 2018, paper 2, question 13. Hopefully you're getting the hang of this by now. A ferry and trawler receive a request for help from a stranded yacht. On the diagram, E, F, T and blah. On the diagram, the points F, T and Y show the positions of the ferry, the trawler and the yacht. Ferry, trawler, yacht. It tells us lots of information in the bullet points. Just check that it's actually already in the diagram. So it says FY is 7.2 kilometres, it is. TY is 5.6, it is. FT is 10.3, it is. And it says that F is on a bearing of 240 degrees from T. 240 degrees from T to F. Good. It says calculate the bearing of the yacht from the trawler. A little bit of a different question this. It's asking us to calculate a bearing this time, not an angle. So the bearing of the yacht from the trawler. So that means it's asking us really, starting at the trawler, go north, turn all the way around, past here, up to here, so I'm facing the yacht. That's what it's asking me to calculate. Don't worry too much if you're not quite sure what it's asking you to calculate, just start off in the same way. Although in this case, as soon as you see 3 sides of a triangle, you should be thinking cosine rule to get an angle. So it's really just identifying which angle it's asking for. So once more time, calculate the bearing of the yacht from the trawler, all the way around to the yacht. So I'm going to need this angle here. So let's just note this angle here. That's the one I'm looking for here. Cos A is equal to B squared plus C squared minus A squared over 2BC. So quite often, again, you'll probably just want to mark your angle as angle A so that you can substitute properly, or I'll always remember really that the one I'm taking away is opposite the angle and the other 2 are the ones that are adding. But let's just mark it A. So for clarity, so if I call that A, that is little a, and then the other 2 is going to be B and C, our sides. So we can then say we've got 5.6 squared plus 10.3 squared minus the 7.2 squared all over 2 times 5.6 times 10.3. That's cos A. You'll get a mark at that point for substituting correctly into the cosine rule. So there's a mark right there. So for our next mark, if we can work out either that cos A is equal to, well, it's 85.61 on the top, over 115.36, or leaving that as a decimal, which would be something like 0.742, that gives us our second mark. Then looking at our third mark, calculating the angle. So A is the inverse cos of 85.61 over 115.36, or the inverse cos of this. And that gives me an angle of 42.008. 088, sorry. So there's our third mark, and then our fourth mark is for calculating the bearing. So just to remind you, the bearing is 240 plus this 42. So we can do 240 plus 42 is 282 degrees for our final mark. And finally, we'll look at an example of using the cosine rule to find an angle. Basically, in National 5 Maths 2019, paper 2, question 7 had this. It had a triangle with all 3 sides shown. Find the smallest angle in this triangle. Now, you may be wondering, how do I know what the smallest angle is? Well, it's pretty obvious just from the way it's drawn as well, but it is this one. So we'll use this as our smallest angle. So I'll relabel that A, and that'll be side A. And then the other 2 sides can be B, side B, and C, side C. Now calculating the angle, I know to use the cosine rule because I'm given all 3 sides. From the start of the exam paper, cos A equals B squared plus C squared minus A squared all over 2BC. You don't need to remember that, you just need to be able to use it. So we'll just substitute all our numbers in, being very careful. So B squared is 8.5 plus 7.2 minus 6.3 squared. you're always taking away the 1 which is opposite the angle, all over 2 times 8.5 times 7.2. That's cos A. If you can get that far, that's a mark. So then we can do the inverse cos of our answer. Now, let's just tidy this up a little bit. If we work out our top, we get 84.4. If we work out our bottom, we get 122.4. Now, at this stage, you can either just divide them to get 0.689 or do the inverse cos of that fraction. It doesn't really matter what you do. And that means that A equals the inverse cos of 84.4 over 122.4. In a calculator, you get A is 46.4 degrees for your final answer. 9. The diagram shows a triangle ABC. Calculate the value of cos B. Cos B? Trig, start the exam paper. Let's go. All the way back. It says the cosine rule. Cos A is B squared plus C squared minus A squared over 2BC. Let me just write that down and copy it down for this question. So we're way down at question 9. So usually the cosine rule is written as cos A equals B squared plus C squared minus A squared over 2BC. And I was going to look at the value of cos B, which is here. So I'm just going to call that A, just to make that the one I want. And that means the opposite side is A, and the other two sides are B and C. It doesn't matter which is which, so I'll just call that B and that C and just substitute. As long as I make my angle A, I'm fine. So we've got cos A equals 7 squared plus 3 squared minus 5 squared over 2 times 7 times 3, 49 plus 9 minus 25, 2 7s is 14, 3 14s, 28, 38, 42. So that gives me 49 plus 9, which is 58, minus 20, which is 38, minus 5, which is 33, over 42. Is that simplified? Well, numbers that go into both of them, I can divide by 3 to get 11 over 14. Now, we've written cos A, remember, but that's actually cos B. So our final answer, to be very clear for the examiner, cos B is 11 over 14. That's my answer. I want to change it to cos A and change the letters to make it make more sense to me, because we're using cos A as the formula. Mr. Klein here for Klein Maths. Today we went through the whole of the cosine rule in National 5 Maths. Hopefully you found that useful. If you did, give it a like. Take care, stay safe, and goodbye.